Hi, I'm Lucas. This is my Part B sort of week 10 update in how my project's going. So I'll start off with what is 2D digital image correlation. 2D digital image correlation takes two images, a reference image that is a sample in an unloaded state and a loaded state. So this is a reference image and the loaded image. It can be anything from a thermal load or an externally applied load. The images are then captured and run through a digital image correlation software, NCORE in our case. The software then attempts to form a displacement field based on the change of position of the pattern. A crude example can be seen below. So what I'm actually testing application methods of speckle patterns. On the left you can see a simple spray paint pattern that had been done previously at the university, and on the right is a theoretical comparison. Is just a comparison between a strain gauge, airbrush and spray paint. I'll be using three methods, which is spray paint, airbrushing and water transfer paper. Water transfer paper hasn't really been used too often, and it'll be an interesting method to see if it pans out. So for airbrushing, there's lots of different ways to do it, different guns, different combinations, different nozzles, different everything. There's also a lot of different mixes for paints and additives. There's thinners, thickeners and hardeners and stuff like that. There's also a lot of different machines. While researching airbrushing and how to apply the patterns with an airbrush, I found a lot of guides and walkthroughs on how to mix paint and thinners. There are a lot of Warhammer and model making forums that have dedicated posts to paint types and their mixing. With little experience in the airbrushing area, there is a lot to learn. A common trend is that it doesn't take long to paint, but it takes a while to know how to paint properly. The use case of airbrushing speckle patterns is also not ideal. Airbrushing is meant to create a superfine mist of paint. Speckles are comparatively large. The settings have to be at low pressure with a lot of paint flow. With time and practice, the patterns could be better. They do produce pretty good results, as seen on the right. So water transfer paper, which is sometimes known as water slide paper, is a type of transferable ink film that is used to adhere patterns to materials. This method's fairly untested, but if proven, could provide a really good application method that has lots of control with regards to the resolution, the design, and the randomness. So the water transfer paper, on the right you can see it's in its form, one of the test samples. It's very clear, and there are additives available to change the properties of it. One of the negatives of it is it is basically an unknown composition. The place I got it from was just Amazon, and when I tried to contact the seller and ask them questions, they basically copy pasted the ad description, which is water slide paper has a water membrane and yada yada yada, which wasn't very helpful. I'm sure if you sourced it from a proper supplier, you'd actually know a lot more. It's an interesting method of attachment. The most common use is for applying decals to trinkets like mugs and cups, or in model making. The quality is very good. There's practically no aliasing, as the pixels are very crisp and clear. It'll be easy for the software to determine where they start and end. The final resolution could have been higher. I'll touch on that later. The biggest concern for the water transfer paper is that the paper won't adhere correctly and will instead be sheared off the surface, sort of sliding up and down as it's getting pulled. Any deformation that occurs in this case will just be the deformation of the actual clear paper, not the sample beneath it. Here's a comparison of the three samples. On the left there's the diagram that they're all based off. Spray paint is pretty thick and hard to control. It serves its purpose very well, as it's been proven before that it's good, but you can see in it that there are a lot of big sort of blobs. This is from the paint being a fine mist, because I am spraying it fairly far back, but the surface tension of the paint blobs mean that when they do attach, they can just join together. This could be mitigated by doing it at a warmer temperature or having the sample slightly heated so it essentially dries on contact. Something to look into. The test samples are all 60-60 aluminium flat bar. 16 samples were made, 5 for each application method, and an additional test sample with a 5mm hole drilled in the center to test the ability of the water transfer paper in a complicated test case. The differences can clearly be seen from the pictures. The spray paint has the largest and least controlled, the airbrush has finer speckles, and the water transfer has the finest and most controlled speckles, given that it is a printed pattern. A printer is a lot more accurate than me spraying spray paint. Each method was fairly easy to apply. Airbrushing was the hardest and most involved. To get it to actually produce what we want, it has to be used in a very unideal case. Like I said before, maximized paint flow with very low air pressure. There's some control at this setting, but not as much as I'd like. This could probably be mitigated by using a different variety of thinners and thickeners, but as this was the first time using it, I didn't want to try anything too crazy and just went with the recommended 1 to 2 mix of paint and thinners. Oh, sorry, 2 to 1 mix, paint to thinners. One of the drawbacks of the paint is that it's on or off. There is no half or 3/4 throttle. The airbrush could do this, although not much paint flowed at the low throttle because it was already at low pressure. The water transfer paper, the world is your oyster basically. The quality of the final finish really depends on the work done before printing. Actually applying the sample doesn't have too much of an effect. As long as you get rid of the air bubbles, there's nothing much that can really go wrong. For the water transfer paper, a somewhat ideal pattern can be generated. Given the nature of randomness, I could just cycle through the pattern and get an even better one, but the rule set I've got for the MATLAB code basically just relies on the rand function. The pattern needs to have some randomness so that the solver can track the unique features and to solve displacement a lot easier. A checkerboard pattern has been theorized as the most accurate, but solvers take a long time to come to a solution, and it's been historically hard to implement. Water transfer paper could be a solution to this. So what I've done, research and more research. A lot of time has been spent trying to understand what a good pattern is and how to apply them. Consolidating previous research, there's been a lot of technical papers on the digital image correlation that focus a lot on the back end of it, so the computational side and the analysis side. A fair amount of the practical work is locked behind commercial software and pre-made systems. There are a lot of systems available that lock you into an architecture, so they provide the cameras and the paint method and everything like that and the software. They are fairly expensive, and all up this test method has been, barring the aluminium cost, has been like $30, and that's buying everything new. The MATLAB program used to develop this pattern is very simple. I did a lot of research trying to get a matrix to place plus-shaped dots at random positions in line with the best practice of 3 pixels width to prevent aliasing. I stopped going down this avenue because you could just reduce the resolution and essentially get the same effect when using single pixels. Plus, the print resolution was probably the limiting factor, given that the camera's resolution is considerably higher, whereas the printer was 1200 by 2400 pixels on an A4 piece of paper, whereas the camera is, I think it was 23 point something megapixels, which is substantially larger than that. There's a lot of potential updates and upgrades that could be made to the code. All I really focused on was getting the coverage, which is the grey to grey, which was about 55% in the end. I think it's 55.04 on the final pattern. The original code was a mess of for and if loops trying to get a nice pattern, and then I found some very helpful documents that simplified it down to this, and it worked very well. Similarly, I did have a code to produce a checkerboard pattern that was really a lot of n plus mess, and then I found that there is a checkerboard function built into MATLAB, which helped a lot. So some of the problems and fixes I had to do. The water transfer paper is similar to a glossy picture paper, which is what the printer was set to. It's not the exact same style, so there are some issues, but it produced very clear results. I printed a test sheet that had multiple 50 by 50 millimeter test squares with various resolutions. The 312 by 312 on the right, although it did look blurry, it was fairly clear, and I decided that was the maximum I would print. On the left, this is the end of the paper on the far left, so the last bit that was printed. There's a clear line down here where it was fairly clear to blurry. This is probably because the print rollers are no longer in contact with the paper, so it jumped a little bit. You can also see the delamination over here where the colors are all separate. To avoid this, I just made sure that I printed a full page and then only took the samples from the right side of the page where this wasn't an issue. The final print resolution was a scaled up 312 by 312. I just multiplied it by the size that it was going to be to fit the page. So it's still got the same pixel density of 38.94 pixels per millimeter. As you can see, this is considerably clearer than the test sheet that I had used. I think this is because when I ran the test sheet, I'd already printed quite a few things that day, and my partner had also printed quite a few things. So the print head was either warmed up or it was a bit runny, led to the blurriness, whereas the actual final print was printed in the morning and nothing had been done. This is a consideration on cheaper printers. It mightn't be an issue, but it's something to think about. Both of these, the paint applications probably could have been better. The spray paint, as I said before, if the samples were warmer, the paint might have dried on contact and the pooling mightn't have occurred. Similarly, the airbrushing probably suffered from the same thing. While airbrushing, it still was producing the actual intended fine mist, so a lot of the background is a bit grey. Instead of having no paint, it's just a tiny little bit, so it looks grey. It shouldn't be an issue as it's not well defined enough to just merge it, so the software should be able to tell the difference. The water transfer paper had a few issues. As I said before, the edges are peeling up a little bit, but that's outside the test area, so it should be fine. When folded over the edge, it looks like a bit of the paint had been rubbed off, just where it touched the corners. It's fine down here, but it has been rubbed off along here. This shouldn't be an issue, but it is a consideration. The adherence in a complex place was surprisingly good. It is the same situation of folding it over a curve, so I think the rubbing of the paint was just user error and pushing it too hard and accidentally scratching it off. So what's left to do? COVID-19 means I'm not allowed to perform it in person. Mitch Gibbs from the workshop is performing them, and it should be completed on the 18th of October. After that, I'll be able to process all the data. It should take about 20 hours for the data, but a lot of this can be done in the background while I'm writing the report and doing other stuff. So the time breakdown. This is the total time spent. Most of it's been research. Quite a bit of it has been doing the MATLAB code and just fixing little things up in it. I did spend a lot of time writing the old codes and then realizing they're not working, starting again to try and write a better code. So a lot of that time was actually wasted, but it is what it is. A better time breakdown is the timeline over time. This is across the whole project. The black dotted line is when lockdown started. It unfortunately coincided right with when the samples were being made. So they were started, and then the next day, the next work day, we were in lockdown and they couldn't be completed. It coincided with a drop in work because I was planning on having the samples and being able to do a lot more work with it. During that time, up until the 29th, which was when I received the samples, a lot of the work had just been every night reading a bit of the document, putting it all together. There was a mad dash once I did get the things to start getting all the ducks in a row and getting everything in an order. It sort of caught up to the line, and now it's continuing along the same trend.